Hey, I'm Rich with the MotoWorks, and today I'm going to show you how to install our RFID Ignition Lock on this 1975 Honda CB125 project bike. Normally, on a CB125, you wouldn't be able to run an RFID Ignition Lock because it's a 6-volt bike. But this one's been modified to have a 12-volt electrical system. That's so we can run some modern parts like an LED headlight and a digital dash. Let's take a look inside the box. First thing you're going to see is an instructional booklet. This is going to tell you how to install and operate the RFID ignition unit, and it includes this handy wiring diagram at the back. We'll come back to this. You see a nice cut foam with all the parts and pieces in it, which includes the RFID ignition lock itself. You can see that it mounts via a single M10 stud, and we include a nut as well. It also comes with 2 keys. The black key turns the bike on and off, and the red key allows you to reprogram new keys in case you lose this one. We have a relay. This is what the current on the motorcycle actually travels through. The lock itself just tells this thing whether to be on or off. We include a 1.5 amp fuse in this fuse holder. That's for the RFID ignition lock, separate from the rest of your electrical system. Finally, some heat shrink crimp connectors to tie it all together. Let's compare our wiring diagram to the RFID ignition lock and relay in front of us. Now there's 3 wires coming out of the RFID ignition lock: white, red, black. Black is our ground. That's going to tie directly to the chassis of the motorcycle. Red is a constant 12-volt power, so that is going to tie via this 1.5 amp fuse directly to the positive terminal on your battery. Yes, that means there is a current draw at all times because the RFID unit checks for the presence of a key about once every 2 seconds or so. But after a few days of no activity, it'll go into a sleep mode and check far less frequently, saving you power. The white wire is a signal wire, and that is going to go from the RFID ignition to the relay and tell it to turn on. All of the current that operates the motorcycle is going to go through the relay itself, never touching the delicate electronics in our lock. So from the positive terminal of the battery, we are going to go through our main fuse, which is good for up to 40 amps, to the relay. We're going to tie to post 87, and then from post 30 on the relay, we will go to our 12-volt system as usual. Make sense? Let's put parts on the bike. So as you can see, I've already mounted the relay using this little tab on the end. I just drilled and tapped a hole in the backbone of the frame. That way the relay will sit underneath the tank, out of sight. For the RFID ignition lock, I'm going to put it under the seat. You can see I have a tab with a hole in it for the M10 stud. This bike uses a simple 2-position key switch with only 2 wires coming out of it, red and black. Now this is a vintage Honda, so green is actually our ground. Black is a switched 12-volt power. So this red wire runs to our battery. So this is going to be what we end up tying into our relay. The black wire will be the output of the relay, and that will go to the rest of the harness to supply power to the headlight, turn signals, taillight, etc. Now, if you have more than 2 wires coming out of your ignition switch, it's a little more complicated. I would look at your wiring diagram to see what gets power from the battery when the key is in the on position. So here we are looking at the wiring diagram for a Kawasaki KZ550. And this right here is our ignition switch. You can see there's 3 positions: off, on, and park. And there's different connections made depending on where the switch is. The RFID ignition lock only has an off and on position, so we're losing the park. But that's okay. I mean, who really uses that anyway? When it's in the on position, you can see that these 2 wires tie together, and these 3 wires tie together as well. These 3 wires don't actually need to be on a switch anymore, so you can just tie those all together permanently. The one that's important is this red wire, which goes to the battery, when in the on position is connected to this one labeled L, which is blue. So our input for the relay will tie to that red wire, and the output will tie to that blue wire. If anybody has any questions about their particular application, we are more than happy to help answer. I've disconnected the ignition switch. I've draped the red wire right over the relay, which I put back in place. That way I know I can trim it right about here and put my new connector on. I'm also going to run a black wire, a new black wire, from this connector to the relay. And I have a ground connector right here, so I'll run a new wire from here to here. So as you can see, I've added the crimp connectors for a couple of the wires already. So we're going to do this red one. What you'll want to do is use your wire strippers and remove just enough material for the wire to go into the supplied heat shrunk connector. Now I've removed the heat shrink. That way when I crimp the connector, it's not going to ruin your insulation. It's also important just use your finger to twist the end of the wire, that way it doesn't fray when you're putting stuff in. And you gotta make sure you put that back in the right way. Goes in like that. Again, just make sure you don't have any loose wires. And put the connector on. Now I have this crimping tool, but a set of wire strippers like this usually has a crimp at the top. Okay, as you can see, I put the insulation back on the connector. So I'm going to grab my heat gun. You only want to heat it as long as it takes to shrink the tubing. Any more than that, you can start to melt the insulation on the wire itself. Alright, with that done, we can start putting these on the relay, tying them all into the harness. The relay is all wired up thanks to the handy diagram. You can see the red wire is tied to post 87, and that ties to our battery. The black wire is our switched 12 volt power. That goes to post 30 opposite the red. Our ground wire is tied in, and that's shown as the green wire. That's going to post 85. Now 85 and 86 look very similar on the small numbers on the back of the relay, so pay extra attention there. The last thing we're going to have to do is tie that post 86 to our RFID unit. Okay, so we're ready to install the actual RFID ignition lock itself onto the bike. Now you can see I've removed a lot of the insulation already. The way I did that is by making a very careful score right here and not even going fully through the insulation, but just enough that I can twist and break it and then cut a slice up the rest of the way. The reason that I'm doing that is because I'm going to be making the connections here, here, and over here, so all three wires need to go to a different spot at a different length. In the event that you say for example, put the RFID unit up here by the handlebars, you'd want to run the wiring down to the tank into your wiring harness, in which case you want to leave that insulation on because it's black, it looks nice. But in our case, since it's going to be entirely hidden, I just went ahead and removed it. I've cut the wires for the RFID ignition lock to size, and I've removed it and brought it back to the bench so that we can now attach our connectors. You can see I've already done the black, that is our ground. This is going to depend, of course, on your specific application. Because I'm working on a vintage Honda, I'm using a male bullet connector, but your bike might vary. Now, we supply bunch of these heat shrink tubing connectors here. Those are meant to connect to your relay, and this one is going to go to your white wire. We also have this inline fuse. You can see there's our fuse, 1.5 amps. That's going to connect to the red wire here. And this is what is inside the fuse holder when you pull it apart. These little guys here are going to be what the wires connect into, and those will just get soldered in place. So we'll go ahead and put that all together now. Okay, so real quick, I just added the other end of the fuse box. You can see this is the wire coming directly off the battery positive terminal. In this case, this battery has a spade connector. Here is the main fuse that goes to our relay. This is a wire that goes to the rectifier. So that gets constant power. You can see I just spliced in a little wire there for that fuse box. That way it goes like right next to this other main fuse. So that about wraps up the different connectors we're going to need, so let's throw it back in the bike and see how we did. I've installed the RFID ignition lock into place and run the wires. You can see the red wire goes to this fuse, which will then go to the battery. The white wire, you can follow along to that final post on the relay, and our black wire, this little guy right here, goes to the ground clip. Now, it'd be worthwhile to check to make sure all of your connections are correct. Double check the diagram, double check the bike's diagram, and if everything looks good, we can plug it in and see if it works. So I connected the battery, which means that the only thing that's keeping this bike from turning on is the RFID ignition lock and the relay. So, got my key in hand. I'm going to give it a try and see if it works. And we have power. Once more, to turn it off. So that about does it for the install of the MotoWorks RFID ignition unit. If you have any questions about your particular application, please feel free to reach out, either on the website, on social media, or down below in the comments. We plan to put out more videos, so if that's something you want to see, make sure you subscribe. Thanks again, and we'll see you soon.